Welcome back, friends. In this lecture, we are going to discuss about infix to postfix using SDT. So here, we will be having some set of production rule and its related semantic rules. So based on this production rule and semantic rule, so we will be converting the given expression uh, of infix to postfix. Okay. So here we will take an example expression 1 plus 2 into 3. So this is the expression we are going to take for converting the infix to postfix using SDT. So first we will be starting from the start symbol. So that is E tends to E plus T. So E tends to E plus T is the production rule. For this production rule, the related semantic rule will be printf of plus. Arithmetic operation plus will be displayed. Then for production rule E tends to T, no operation. Then for production rule T tends to T star F, printf of star. Okay, that multiplication operator will be printed for this production rule. For T tends to F, again no production. Then for the final production, F tends to num. So num is the terminal value. So if you are encountering the production rule F tends to num, it will print the numerical values. That is the numerical values are the lexical values for this production rule. So which is stored in the symbol table. Okay. So we will divide this expression into two parts. One is this part and another one is this part. 1 plus 2 is one part and 2 star 3 is another part. So first we will be having the plus operator. So we will start from the start symbol. E tends to E plus T. Okay. So E tends to E plus T. So E tends to E plus T has been mentioned. So arithmetic, this plus operator has been mentioned here. So after that, we need to get these values. Num values are 1, 2, and 3. So for this, we have to get the num value 1. So this E can be further expanded as T. So E tends to T. And T can be expanded as F using the production rule. T tends to F. And F tends to num. Okay. F tends to num. So this will be having the number value 1. Then coming to the right hand child, so okay, right end of the child, right child. So in this thing, you have to expand the T to T star F. Then only you will get the multiplication operator. So this T again expanded as T star F, T star F. So this T again can be expanded with F. So in order to contain, represent the number value that is 2, and this F will be representing the number value representing 3. Okay. So now you can see here, we got the number value 1, 2, 3. Now we will start traversing the tree. So in order to convert this expression to postfix. Okay. So first thing, what is the first production rule? So here we have to start with 1. So postfix expression means we know that generally, so the operator will be at the end of the expression and the operands will be at the beginning of the expression. So beginning we should have the operands. So the values should be present in the beginning. So we will be starting from F tends to num. So what is the production rule? F tends to num specifies the semantic value is printf num dot L value. Here we have to print the number value. So here the number value is 1. So here the number value is 1 that is printed. So this has been completed. Then you have to see T tends to F. So T tends to F. There is no production. So sorry, there is no action. So leave it. Then E tends to T. So E tends to T is also no operation. Leave it. So next we have to go for this E. In order to evaluate this E, we have to perform the operation of this T. Okay. So in order to perform the operation of this t, again, we have to start from the num value. So here, so it will be mentioning here. Okay. So again, f tends to num. So what f tends to num specifies? F tends to num specifies printf num dot l value. Here the num value is 2 that has been printed here. Then t tends to f. So t tends to f. There is no operation. Leave it. Then in order to substitute this, in order to identify the value of this t, this right hand child has to be substituted first. So again, start here. So again, f tends to num value, that is 3, that has to be printed according to the semantic rule of this production. F tends to num. So print of num dot l value. Here the l value is, num value is 3, that has been printed. Again, you have to go to this t. Now, if you are going to this t means, what is the production rule? T tends to t star f. So t tends to t star f means the semantic rule performed should be performed as printf of star. So this star will be printed here. Okay. So now we have identified the left child E and right child T. Then you can go for this E. So what is the production rule of this E? E tends to E plus T. So for this production rule, E tends to E plus T. We have to print the statement. So printf of plus. So plus operator will be performed here. So this is how we can convert an expression from infix to postfix using syntax directed translation. So based on this production and semantic rule, first we will construct the parse tree, annotated parse tree. From that parse tree, with the help of this parse tree and the semantic rules, we can easily convert the infix to postfix operation. I hope you can understand the concept. Thank you.